the very start of our course, we mentioned that fundamental physics principles applied to these amazing observations could be used to provide evidence for the existence of a black hole, and, moreover, that these observations could be used to estimate the mass of the black hole. Well, we now know enough motion physics to perform this kind of analysis. This motion problem is another case of finding forces starting from observations. We know the steps for solving problems like these. Beginning with identifying the system whose motion we're studying, we use observations of the system's motion to find the total force, the net force acting on the system. We next specify the particular interactions that contribute to the net force, and finally solve for unknowns in the problem. So for this lab, we're going to do all this for a case where we have been given observations of the motion of some visible star, which is our system for this problem. The first main task we face is to analyze the observations to extract the net force acting on the star. The observations are contained in a CSV file listing the x and y positions of the star recorded at a time interval of 1 Earth day. We also know the mass of the visible star. To help us with the analysis, we can start with a Python program, which you can download along with the file containing the observations and other supporting files using the link which should pop up now. If you run the program, you should see a green line that traces the trajectory of the star's motion. If you see this, then the program you're using is correctly reading in the position data of the star. Now you'll have to edit the rest of the program to put in other information and the physics principles and concepts you need to find the net force on the star, including the parallel and perpendicular components of FNet. It's good to notice here that the structure of this starter program should look very familiar. We used a very similar program to analyze the motion of a mystery object in a recent lecture. The analysis we need to perform here follows the same steps, so it would be a good idea to review our earlier discussion before starting to analyze the star's motion to find the net force. Once we have the net force in hand, we can then proceed to specify the interactions that contribute to FNet. Although we can't see an agent in the surroundings, we are going to make a reasonable assumption. We'll assume that the total force is due to only a single force from some agent interacting gravitationally with the star that we can see. Further, let's assume that by some means we know this unseen agent is located at the origin of our coordinate system. With all this in mind, we can use Newton's universal law of gravitation to describe the interaction of the unknown agent and the visible star. Combining this with selected results from our motion analysis, we can then solve for the unknown, an estimate of the mass of the unseen object, a black hole at the origin. So let's go ahead and do this lab. If you run into any troubles, feel free to discuss these in the class forum. Good luck and have fun!